In this lesson, we are going to learn how to find missing measurements of a right angle triangle using trig ratios. For you to be able to do this lesson, you must have already known what trig ratios are. So a prerequisite to this lesson is a lesson on trig ratios, and we're going to be using SOH CAH TOA to find the angle measures. I'm also going to introduce you to arcsine, arccos, and arctan. So here's a review first, very quickly, on trig ratios. It's going to be very important for you to always determine what angle you are focusing on and then label the sides according to the angle that you are focusing on. So in this example, if you're focusing on angle E, you would label these sides of adjacent, hypotenuse, and opposite in this way. If you were to say find the sine of E, you would obviously know SOH, opposite over hypotenuse, you do 12 over 20, and you would get that the sine of E is simply 0.6. Here is a right triangle once again, where we're going to be focusing on angle C, and you are going to be able to solve all the sides of this triangle, this time using SOH CAH TOA. So of course the first thing that you should do is once you're focused on an angle, you should always label your sides of opposite, adjacent, hypotenuse according to that angle C. And I've done so here. So what we're first going to do is we're going to try to find what we can based on what we're given. So we're given that this angle here is 54, and we're given that the hypotenuse is 65. In order for us to find something left over, it would make sense for us to use SOH, because we have that the sine of 54 is, well, you know what the sine of 54 is, but you also have that the hypotenuse is 65, and we can easily find the opposite side. So we're going to do some simple cross multiplication, and we are going to find that side AB is 52.59 centimeters. So by using the trig ratios, we are able to find what side AB is. On the other hand, if we wanted to, we could also use the cosine trig ratio and instead done adjacent over the hypotenuse, and then also find what what line segment BC is. Line segment BC can be found if we're going to do cosine of 54 is equal to the adjacent sine over the hypotenuse, which we know is 65. We're going to cross multiply once again, and then we are able to find that BC is 38 centimeters. Of course, once you find one of the sides, you can use Pythagorean theorem to find the last side, but this is just a very easy way for you to see that you can use trig ratios in order to find side lengths and cross multiplying by doing so. How do we calculate the angles that we're missing though, however? So of course you should know that the sum of the interior angles of a triangle are equal to 180 degrees, and if this is a right angle triangle, then you'll know that you can do 180 minus the 54 and the 90 added together to give you the leftover side as 36. But I'm going to also want to show you how you can use sine, cosine, and tangent to do that instead. So in this case, we are going to, knowing that A is 36 based on our last slide, we're still going to find an angle using trig. So the first question I have for you is, what is the sine of A? If we're going to do the sine of A, we first have to focus on A and label our sides according to A, opposite, adjacent, hypotenuse. Then we're going to do SOH. So sine of A is equal to opposite over the hypotenuse. In this case, it's going to be 38 over 65, and we get that the sine of A is equal to 0.58. It's great that we have the sine of A, but we want to know what A is. We want to know what the degree measure of the angle of A is. And this is where you're going to need to find the sine to the -1 symbol on your calculator. If you were to use your calculator and plug in sine -1 of 0.58, what would you get? If you do this, you might get something that looks like 35.45 on your calculator. And we already know by doing the sum of the interior angles of a triangle that A should be 36. In this case, you were able to find the angle measure without doing the sum of the interior angles of a triangle by using this sine to the -1 button. So what is that? I'm going to introduce to you right now the three important things for us to solve angle measures. They are called arcsine, also known as the inverse, the sine inverse. That's what the -1 means. Arccosine, aka arccos, which is cos to the -1 or cos inverse. And the last one, which is arctangent, aka arctan, and this is tan to the -1 or tan inverse. All of these here should be easily found on your calculators. You're going to use these three things after you've found either the sine, the cosine, or the tangent of a corner to find the angle measure. So understand that if you're using sine, you're going to then use arcsine. If you're using cosine, you'll use arccos, and if you are using tan, you're going to use arctan. You cannot use arc cos if you were using a sine, for example. So here's another example where I've given you only the side lengths of this right angle triangle. So in this case, let's just start with angle F just because, and we're going to label our sides accordingly. And we're going to use SAW just because. We're going to do all of them, but let's use SAW. If we're going to use SAW, we're going to do the opposite over the hypotenuse, which gives us that the sine of F is 0.81. However, we don't want 0.81, nor do we want the sign in front of the F. So we're going to inverse it. We're going to inverse the 0.81, and we're going to get that the actual angle F is 54 degrees. On the other hand, you could also have used cosine, which you would have done in the adjacent over the hypotenuse instead. Get that the cosine is 0.56, but then need just F. So then you would have to plug in the cosine or inverse 0.56, which will then equal to 55 degrees. So you might notice that it's a bit off, but it's not a huge difference if we're talking about a 54 and a 55. And last but not least, you could have also used TOA or the tan function by doing the opposite over the adjacent, which would be 13 over 9 in this case. Tan of F is equal to 1.4, but once again, we don't want tan of F, we just want F. So because we're using tan, we'll then find arctan and do that the tan inverse of 1.4 is 54 degrees. So we have 54 degrees here and 55 degrees, but you know that it's something along those lines. You will definitely get different answers, but they are not going to be far off from each other. So in this case, we're just going to use the 54 degrees and move forward. So now that we know that, we still know enough to find what the remaining angle is, angle D is, by doing our sum of the interior angles rule. But we are still going to check it using trig ratios because that's the purpose of this lesson. So focusing on D, we're going to label our sides accordingly. And using SAW, we could find that the sine of D is 0.56 by doing opposite over hypotenuse, but then we would do the inverse sine and get 34 degrees. We're aiming for 36 degrees, but once again, don't worry, you will, especially with rounding, you will get similar yet different answers. If we were to use cosine and do adjacent over hypotenuse, which is 13 over 16, we would get that the cosine is 0.81, but the inverse cos, which is what we want, is 36 degrees. And lastly, you could have again used TOA, especially because we have all of the sides. TOA, meaning opposite over adjacent, would be a 9 over 13, and it would be 0.69. However, the arctan of tan is 35 degrees. So we have 34, 36, and 35 degrees, knowing that we're aiming for 36 degrees, but these are all acceptable answers. So in the end, we're going to pick 36. With all three side lengths, we were able to find all of their angles using trig ratios, but then also accentuating it using our sum of the interior angles rule. So now I would like you to try this on your own by finding all the missing measurements in this particular triangle. Of course, you could always use Pythagorean theorem when possible, but for the purpose of this lesson, it would be really great if everybody would try to use trig ratios for this example. Now you're welcome to pause this video and do it yourself, or just press play or continue watching for the answer. I'm first going to start with finding angle Z. That's what I decided that I was going to do, and so I was going to label my sides according to it. Now, I don't have my adjacent side right now, and I only have the opposite and the hypotenuse, so I'm sure you can guess that I'm going to use sine. Sine tells me that opposite over adjacent means that it is equal to 0.74. But once again, I don't want the sine, I want the actual angle measure, so I'm going to use arcsine to find that the angle measure is actually 48 degrees. Since I know that, I'm going to find angle x, which yes, you could do 180 minus 90 minus the 48 to get x, but I'm going to use trig ratios. And in this case, if I focus on x, my labeling changes and I'm actually given the adjacent and the hypotenuse in this case. So I'm going to do 76 over 103 for cosine, and I'm going to get that the cosine of x is 0.74, but the arc cos is 42 degrees. So that's what I get for x using cosine trig ratio. But again, you could have used the sum of the interior angles of the triangle to find it. If you use angle Z to find your missing side and not Pythagorean theorem, we're still going to label our sides according to Z, like we did to find its angle measure. And you'll notice that you need the adjacent side. It's what you need. So you can do this either using whatever ratio gives you a hypotenuse and whatever ratio gives you an opposite side. So here we have TOA. So TOA is opposite over adjacent. So I have that the tan of 48, which I know is 48, is equal to the opposite side, which is 76, over the adjacent side here. And I'm going to cross multiply to find that the ZY side is equal to 68.43 centimeters. Or I could have used cosine to find that same line, and then the cosine of 48 is equal to the adjacent side that I don't know over the hypotenuse that I do know, cross multiply, and still get something rather similar to when I used tan. If you decided that you were going to use angle X to find our missing side ZY, labeling it accordingly, you could use either TOA to find the opposite side, using that the tan of 42 is equal to the opposite side over the adjacent, which is 76, cross multiplying gives you 68.43. Or you could have used sine or SAW, with the sine of 42, because we're focusing on 42, is equal to ZY, which is the opposite side over the hypotenuse, which is given to us as 103. Cross multiplying, we get the same exact thing that we did when we focused on Z, which is approximately 68 centimeters if we average it out. Here are some notes for you though. You could use Pythagorean theorem once you have two sides of the right triangle. You could always use the sum of the interior angles of a triangle to find the missing angle. The purpose of this lesson though is for trig ratios, so that's why I used it. Also, depending on how you decide to round your decimals, maybe you do it right away on your calculator without stopping rounding and using an answer. But if you decide to round at any point in time, all answers will typically range within two numbers in order for us to be consistent. In conclusion, given any one side or any one angle of a right angle triangle, you can always find the missing measurements, which in this case consider angles and side lengths. You should know SOH CAH TOA, and you should know the sine inverse, the cos inverse, and the tan inverse. Some fun facts though to conclude this lesson is that if you have a 30, 60, 90 triangle, it's really interesting to note that the length of the side opposite the 30-degree angle is actually always equal to half the length of the hypotenuse. So what do I mean by that? So here's a 30, 60, 90 triangle, and AB is opposite 30. If the hypotenuse AC is 40, then AB, the side opposite 30, is half of 40, which is 20. If the hypotenuse is 10, then the side opposite the 30 is 5, and so on. Also, in any right triangle, if the legs of a triangle are 3 and 4, 3 here and 4 here, the hypotenuse will always be 5. And this concludes our lesson of missing measurements with trig ratios.